To illustrate the application of the two-stage least squares or 2SLS model, we will use a simultaneous equation model known as the Klein Model 1. This model was introduced by Lawrence Klein in 1950. The Klein Model 1 consists of 6 equations and 6 endogenous variables. These endogenous variables are consumption, investment, income, wages, corporate profits, and capital. The exogenous variables in the model include government expenditure, government wage bill, trend, and taxes. In addition to these, we also have some predetermined variables including the lag of corporate profits and the lag of capital stock. We call them predetermined because, in any time period t, we know the values of variables in time t-1 or the previous time period. The last 3 equations shown here are the identity equations. These equations don't need to be estimated using 2SLS as they do not contain any parameters. We will estimate the first 3 equations and the parameters of this Klein Model 1 using 2SLS. The first equation shown here is the consumption equation. Consumption is a function of corporate profits, lag of corporate profits and total wages including both private and government wage bill. In this equation, total wages and corporate profits are endogenous variables on the right-hand side and these are related to the error term mu1. We cannot use OLS to estimate this equation due to endogeneity. The second equation of investment contains one endogenous variable corporate profits which is related to the error term mu2 causing endogeneity. The other variables lag of capital and lag of corporate profits are predetermined variables. Finally, the equation for private wages also contains one endogenous variable causing endogeneity. This equation also has an exogenous variable trend and a predetermined variable. Since 2SLS model is a single equation approach to simultaneous equation models, we will estimate the first 3 equations one by one using 2SLS. In R, we can use the AER package to apply 2SLS or two-stage least squares. The AER package provides a function called ivreg that is used to estimate a 2SLS model. We will use the same data used by Klein to estimate this model. The data consists of 22 annual observations from 1920 to 1941 in the United States. This data contains all the variables that we need to estimate the Klein Model 1 and is available within the AER package and the SystemFit package in R. First, let us apply the 2SLS approach to the first equation of consumption in the Klein Model 1. As we saw earlier, consumption is a function of corporate profits, lag of corporate profits and total wages. Total wages and corporate profits are endogenous variables in this equation. We can use the following command to estimate this equation using 2SLS. The option of data is equal to z simply tells the function which dataset to use. In our example, the dataset is stored in the object z. Here, consump is the dependent variable of our equation followed by the independent variables of corporate profits, lag of corporate profits and wages. This represents our consumption equation. However, we also need to mention the variables or instruments that will be used in the first stage of 2SLS to estimate the reduced form equations. The variables mentioned afterwards are the instruments that will be used in the first stage. These include all the exogenous and predetermined variables of our model and dataset. These will be used as the independent variables in the first stage. You will notice that corporate profit and wages are not mentioned in the instruments, but lag of corporate profit is included. This is because lag of corporate profit is predetermined whereas corporate profit and wages are endogenous variables. This way, the software knows which variables are endogenous and which are exogenous or predetermined. Therefore, in the first stage, the function will automatically estimate the reduced form equations of endogenous variables corporate profits and wages as function of all the exogenous variables mentioned here. Then, it will automatically obtain the predicted values of these endogenous variables and use them to estimate the second stage of 2SLS. We can use a similar procedure to estimate the investment equation and the private wage equation of the Klein Model 1. In the command shown here, investment is the dependent variable. Corporate profits, lag of corporate profits and lag of capital stock are independent variables. Similar to the consumption equation, we mention all the exogenous and predetermined variables of our model as instruments here. The software will automatically take care of estimating the first and the second stage. In this investment equation, we have only one endogenous variable: corporate profits. So, the first stage will only estimate the reduced form equation for corporate profits and use its predicted value in the second stage. Similarly, we can estimate the private wage equation using the command here. Private wage is the dependent variable, whereas gross national product or GNP, lag of GNP and trend are independent variables. The instruments stay the same in all the equations because our model has the same exogenous and predetermined variables that are used in the first stage. In Stata, we can use the IV regress command to estimate this model using two SLS. First, let us estimate the consumption equation of Klein Model 1. In the command shown here, option 2 SLS is used to estimate using two-stage least squares. We can also use the options LIML for limited information maximum likelihood and GMM for generalized method of moments. Here, consump is our dependent variable in the consumption equation. Then, we mention the exogenous and predetermined variables that are included in the equation. The lag of corporate profits is the predetermined variable that is part of the consumption equation. After that, we mention all the endogenous variables that are included in the consumption equation, that is, corporate profits and wages. Finally, we list all the exogenous and predetermined variables that are excluded from the consumption equation. These will act as instruments in the first stage along with included exogenous variables. We have 6 excluded exogenous and predetermined variables including government wage bill, government expenditure, trend, taxes, lag of capital and lag of GNP. The first option can be used to report the results of the first stage of 2 SLS. By default, only the results of the second stage of 2 SLS are reported. Similarly, we can use the following command to estimate the investment equation. Here, investment is the dependent variable. Lag of corporate profits and lag of capital are the included exogenous and predetermined variables that are part of the investment equation. In this equation, corporate profit is the only endogenous variable to be mentioned here. The excluded exogenous and predetermined variables are government wage bill, government expenditure, trend, taxes and lag of GNP. In case of the private wage equation, we can follow the same procedure. First, we mention the dependent variable of the equation, private wages. Then, we mention all the included exogenous and predetermined variables, lag of GNP and trend. The GNP variable is the only endogenous variable in the equation, after which we mention all the excluded exogenous variables. This way, we can estimate each equation of the Klein model using 2 SLS. Now, let us take a look at the results of the 2 SLS model. By default, most software packages report only the results of the second stage. Still, some software also give us the option to report the first stage. Let us take a look at the second stage or final results of the 2 SLS model for the consumption function in the Klein Model 1. The reported results contain the usual information like the coefficients, standard errors, t and p-values. The interpretation of these coefficients and p-values are similar to what we have in ordinary least squares or OLS. We can say that the coefficient of wages is 0.810 and is significant at 1% level. The coefficient of lag of corporate profits is 0.216 and significant at 10% level. Finally, the coefficient of corporate profits is not significantly affecting consumption. Remember that wages and corporate profits were endogenous in the equation. This means that the original variables of wages and corporate profits were not used in the second stage. Instead, their predicted values from the first stage were used. That is, the predicted values of wages and corporate profits from the first stage reduced form equations were used to estimate the consumption equation here. Since wages and corporate profits were endogenous, we know that the OLS estimates will be biased and inconsistent. Let us compare the results of two SLS and OLS estimates to see how different the coefficients are. This will also help us see the bias in OLS estimates. In the table here, the coefficient of wages is underestimated a little by OLS as compared to two SLS. The difference in coefficients is not large though, and the coefficient is significant at 1% level in both OLS and two SLS. We can also see that the coefficient of corporate profits is massively overestimated by OLS. The OLS results show the coefficient to be significant whereas it is insignificant in two SLS results. Similarly, the coefficient of lag of corporate profits is underestimated by OLS and is insignificant. Such a huge difference in OLS and two SLS results is due to endogeneity because the OLS estimates are biased and inconsistent. The results of the investment and private wages equation can be reported and interpreted in a similar manner as well. When looking at the results of the two SLS model, we should watch out for a few things. First, software packages generally report R-square values in the results. However, R-square is not a good measure of goodness of a two SLS model and should not be used. In some cases, you might notice that R-square is negative or simply not reported in the two SLS model. A negative R-square or no R-square is a cause for concern in OLS but not in the two SLS model. If you see a negative R-square in two SLS, do not worry. This can happen because we use predicted values of some variables in the second stage of two SLS. R-square is not appropriate when we use instrumental variables like in two SLS. Second, we know that two SLS is estimated in two stages. In both stages, OLS is applied first to obtain the reduced form equations and then to estimate the second stage using predicted values from the first stage. So, we can manually apply the OLS in two stages instead of using a function designed for two SLS such as IV regress and Stata. However, this is not advisable because the standard errors and the resulting statistics will be different. The functions designed for two SLS compute standard errors in a different manner than OLS functions. Finally, we must be sure that applying two SLS is justified and that the results of two SLS are reliable. In the next tutorial, we will discuss certain goodness of fit statistics to check whether the two SLS model is appropriate or not. Thank you for watching and I will see you in the next tutorial.